Hi everyone and welcome to my channel. I'm Eugene and this channel is dedicated to teaching of programming and software development. In the previous lessons, we learned how to solve problems using loops. In this lesson, we are going to learn an alternative to loops that may be better in solving some problems. In this lesson, we are going to learn about recursion. It's not very intuitive from the beginning, but it gets easier with practice. First, let's talk about the idea of recursion. Consider we need to solve a hard problem. For example, build a house of 4 floors. We can think of two approaches to solve this problem. In the first approach, we can divide the house to floors, and then, beginning with the first floor, start building it. Once the first floor is done, we can build the second floor, then the third one, and then the fourth one. In terms of programming, this approach is actually using a loop. Iteratively, we build the floors one after another. The second approach has a little different idea. We want to build a house of 4 floors. Since building a house of 4 floors is not a simple task, we can think of it in the following way. If someone could provide us with a house of 3 floors, we would easily add one more floor. But building a house of 3 floors is also difficult, so we will ask for a 2-floor house. But a 2-floor house is also difficult, so we'll ask for a single-floor house. Well, we know how to build a single-floor house, so this time we don't need to ask for anything. We just build it, since the task is already simple enough for us. Now that we have a single-floor house, we start going the whole way back. Earlier, we asked for a single-floor house to build a 2-floor house. So now we can build the second floor and get a 2-floor house. Once the 2-floor house is ready, we return it to the one who asked for it, and now we can add another floor and build a 3-floor house. And once it's done, we can add another floor and get a house with 4 floors. This approach is called recursion. We solve the hard problem by asking for the solution for a smaller problem. Once we have it, we can easily solve the hard problem on top of the simple problem solution. Now, let's take this idea to programming. Recursion is a programming technique where a function solves a problem by calling itself on a smaller or simpler version of the same problem. And it continues calling itself until it reaches a point where it no longer needs to call itself because it can solve that small version of the problem. Now, as you may have noticed, recursion has two main parts. The base case. This is the simple version of the problem that we know how to solve. This is when we stop calling the same function, but just return the answer. In the analogy to building a house, this is the single-floor house that we know how to build. And we have the recursive case. This is the version of the problem where the function calls itself with a smaller or simpler input. This is when we asked for a house with 1 floor less. We asked for a solution for a simpler problem because it helps us in solving the harder problem. And this is the general idea of recursion. Now, recursion is used in many places. For example, when we need to walk over tree-like structures, like file systems, where we walk over directories that can include other directories or files. Recursion is used in algorithms for sorting arrays, for example. We'll get to sorting arrays in another course, this is just to give you an example. Another example is actually solving mathematical problems that are recursive by nature. For example, factorial. The factorial of 5 is 5 multiplied by the factorial of 4, and so on. And there are many more examples, but I hope you get the idea. Now, when using recursion in C#, we actually have a method that calls itself with a simpler input. Notice that the method should have to return an answer to the problem it can solve without calling itself again. It must be able to solve the simplest problem. If we don't return an answer but just call the same method, we will continue with the recursion without stopping. We will stop at some point, but just due to memory limitations, which is not what we want, and we won't get an answer in this case. Let's take a look at a simple example and see how it works. As you can see, in this example, we calculate the factorial by calling the same getFactorial method with a smaller number. If the getFactorial method gets 1, it simply returns 1. Now, let's see an example of execution of the method we've just seen to better understand the idea. Consider that we called the getFactorial method with the number 3. First, the getFactorial method checks if n is 1. Since it's not, it continues. Then it calls itself with the number 2. Now, getFactorial checks if n is 1, and since it's not, it calls itself with the number 1. GetFactorial checks if n is 1, and since it is, it returns 1 to the method that called it. Now we are back in the previous method with the number 1 as the result. Now we multiply 2 by 1 and return the answer to the previous method. Now the first method gets the result 2 and multiplies it by 3. Once it has the result, it returns it. As you can see, in this example, n of 1 is the base case, or the simplest version of the problem that we know the answer for. This is where we check if n equals 1. And the recursive case is for the numbers that we don't know how to calculate factorial for, and we call the same method with a smaller input. Notice that if we wouldn't have the base case, we would continue infinitely. As I said, not exactly infinitely due to technical reasons, but we are not going to cover those reasons at this point. To summarize how a recursive method looks like, here's a very abstract template. This code doesn't compile, it's just here to show you the main parts of a recursive method. As you can see, every recursive method has two parts: the base case, in which the method returns an answer, and the recursive case, in which the method calls itself. Now, let's go to VS Code and see some examples. Alright, now we're in VS Code, and we are going to see two examples. The first example will be a method that calculates the factorial of a number. First, let's see what factorial is. So, factorial is the multiplication of all numbers from the number that we give it from the given number to 1. So, for example, factorial of 5 is 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1. And it equals 120. Alright, now let's write a method that performs this calculation. Okay, so the method will return an integer and we'll call it getFactorial. And it receives the number n. Alright. Now, as I already explained, every recursive method has two parts. And the method should solve the most simple problem which is actually the base case. All right, and the most simple problem in case of factorial is when n is 1. All right, so let's write it. If n is 1, we can also add or n equals 0, because by definition the factorial of 0 is also 1. So in this case, we are going to return 1. But what happens if n is a number larger than 1? In this case, we need to first calculate the factorial of the number smaller than the given one, and then multiply it by n. And we can actually do it in a single line. We can immediately return the result of n multiplied by get factorial of n minus 1. So if n is, for example, 5, then we are going to skip this if block. And what we are going to do is we are going to do the following. We will first go into the get factorial method again, but this time we are going to call it with n minus 1, which means we will call it with 4. And once we have the result of this, we are going to multiply it by 5. And the method will call itself until it is called with n of 1. Once it is called with n of 1, it returns a value, and then it goes the whole way back. Now, let's call the method and see how it's working. So, all right, for example, let's call it with the same number 5 as we just said. Or let's do it even like this, int factorial result get factorial of 5. All right, and now let's print the result. Okay, now let's run this. And as you can see, the result is 120, which is correct. Now, I would also like to debug this method to show you how it actually runs. So let's put a breakpoint just before we call the method and debug it using this button. Okay, now, as you can see, the method wasn't called yet, and we are just before we enter the method. Now, let's get inside the method. Okay, as you can see, n is 5. Now what we do is we check if n is 1 or 0, and if it's not, we just skip the if, and this is actually what happens. And now you see that we will multiply 5 by the result of get factorial of 5 minus 1, which is 4. And now we are going to enter the get factorial method again. I'm going to step into, and as you can see, this time we are inside the same method, but with the value 4. And if we continue, then again we are going to skip the if. And this time we will call get factorial with 3. You can also see the n here in the locals pane. You can see that it's 3. Again, we will skip the if and enter the get factorial method with the number 2. And if we do it again, we are going to get into the get factorial method with the number 1. Now, since n is 1, we are going to get inside the if statement and return 1. Now, pay attention that once we return 1, we are going to get back to the previous get factorial method that called it. And once we did, you will see that we are again at this line, but this time n is again 2 because we are back in the previous method. Okay, now what we are going to do is to multiply n by the result that we just received. And this time we are back to the previous method where n was 3. And we are going to continue like that until we return the answer from the method. Now, once the method returned, you can see that the factorial result is 120. All right, and this is the general idea of recursion. Now, let's see another example. In the second example, we are going to write a method that returns the nth number in the Fibonacci sequence. First, let's see what the Fibonacci sequence is. Let's delete everything. Now, the nth number of the Fibonacci sequence is defined as the n minus 1 number of the Fibonacci series plus the n minus 2 number, which means it's the sum of the previous number in the Fibonacci series and the previous of the previous. Now, for Fibonacci of 1, it simply is 1, and for Fibonacci of 0, it's just 0. Now, as you can see, the Fibonacci sequence is already defined in a recursive way. Now let's try to write this method. Okay, so the method is going to return an integer, and we'll call it just fib, and it will get again n as its parameter. All right. Now let's begin with the base case. As you can see, for the input of 1, we return 1, and for the input of 0, we return 0. So we'll do it like this. If n equals 0 or n equals 1, we will just return n. All right. Now, if n is something bigger than 1, we actually need to calculate the Fibonacci of the previous number and the previous of the previous. All right, but this time I'm going to write it a little differently. Okay, I'm going to define a variable a, which will get the result of fib of n minus 1, then int b, that will get the result of fib n minus 2, and then we are going to return a plus b. All right. Now, as you can see, in case of n is 0 or 1, we are going to return the same number. And then we are going to calculate in case n is not 0 and not 1, we are going to first calculate the Fibonacci of n minus 1 and then the Fibonacci of n minus 2. After we get both results, we are going to add them and return the result. Okay, now let's try to run the method and see how it's working. Okay, for example, let's see, let's try to run it with Fibonacci of, all right, let it be 5 again. Okay, first let's try to just run it. All right. As you can see, the result is 5. Now, the Fibonacci sequence looks like this. It begins with 0, 1, then again 0 plus 1 is 1, then 1 plus 1 is 2, 1 plus 2 is 3, and 2 plus 3 is 5. So if we run Fibonacci of 5, we will see that this is the 0th element, 1, 2, 3, 4, 5. All right, now let's debug this method to see how it's working. We'll put a breakpoint here and let's debug this file. All right, so let's get inside the method. Now, as you can see, n is 5. So we are not going to get into the if statement. Now, what we are going to do is call Fibonacci with the number 4. And this time, as you can see, we are in the same method, but with the number 4. All right. Now we are going to call the same method, but with the number 3. Then we are going to call the same method with the number 2. And then we will call it with the number 1. Once we call it with the number 1, we are going to return 1. Okay. Now we are back in the previous method where n was 2. And now, as you can see, a has the result of Fibonacci n minus 1. Now we are going to call Fibonacci with n minus 2. All right. Pay attention that we are not starting from the first method, but we continue from the method that just called Fibonacci before. And if we call it this time, you can see that n is 0. And since n is 0, we are going to return 0. Now we have both a and b, which are both results of the of calling the Fibonacci method. And a is 1 and b is 0, which are actually the first numbers of the Fibonacci sequence. And now we are going to return the result of adding those two numbers, and we return it again to the method that called it. And now a is 1. All right. Now we are going to call Fibonacci with n minus 2. And this time, again, since n is 1, we are going to return 1. And now we have the result of both calls to Fibonacci. So a is 1 and b is also 1, which actually makes sense because these are the next, these are the second and third numbers in the Fibonacci series. All right. Now we are going to add those two numbers and return the result to the previous method. In this method, n was 4. And now, again, we are going to call the same Fibonacci method, but this time with 4 minus 2. And I'm not going to get into this method again because it's actually absolutely the same. So I'm going to just step over. And now once we get the result, you'll see that we have 2 and 1. And the result is actually 3, which is the next number in the Fibonacci sequence. Now, if we call Fibonacci with 5 minus 2, which is 3, you will see that b is 2. And if we add those two numbers, we'll get actually 5 as the result. And this is actually how it works. All right, this was an interesting lesson that gives you a powerful tool to solve many problems. It might look hard in the beginning, but you will see that it gets easier with practice. Thanks for watching and see you in the next lesson.